I am very pleased to introduce our first speaker, Peter Orgill, who is going to talk to us about the street detective using R and Tableau to understand crime. So Peter has been involved in data for more than 15 years, firstly as a DBA and now as a Tableau developer. And he's also currently completing his master's in statistics. So Peter, I'll turn it over to you.
Thanks, Emily. I'll share my screen and let's get going. Okay, straight into it, no performance. I'm assuming everyone can hear me okay. First steps is to install R, which is really straightforward. We can install the package via a menu option in R Studio. So install R, then install R Studio, then install the packages, which I've already done. And R Studio is pretty smart. If it doesn't find it locally, it'll go to the internet and install it for you. And then you just specify the library and you connect. So R Studio, R server is running. Next step is to connect Tableau to R. Again, really straightforward. Help. We need to be on the dashboard. Help. Settings and performance. Manage our connection. Again, I'm running everything locally, so it's really easy. If you're in an enterprise, then you probably have to deal with server names and firewalls and things like that. I don't, thankfully. And actually, I might will connect that. So just restart it off. Probably reconnect that. Next step, let's just talk about the data that I'm using. It's Boston house prices. So I'm going to look at an old data set that's quite a famous one for econometrics. We can open that up and have a quick look. It's publicly available. It's based on US Census data. And we've got 14 variables. The main one I'm going to look at here is crime per capita by town. And that's my predictor, or my independent variable, if you like. And my Y, or my dependent variable, is median value of owner-occupied homes in $5,000. The data set's very old, but it's very famous and it's very interesting. And it was originally used to look at the demand for clean air. But I'm going to look at the relationship between crime. I'm going to look at so this is really basic stats 101 hypothesis testing. Null hypothesis: crime is not a significant predictor of house prices. Crime is a significant predictor of house prices. So we can quickly jump to Tableau. And I think everyone knows how to produce a scatter plot. Pretty straightforward. Not that one. And I have Boston house prices on my y-axis. I have Boston crime rates on my x-axis. And if I right click and describe the trend line, you don't have to be a statistician to look at the p-value and see that this is a highly significant relationship. P-value less than whatever it is, 0.0001. Okay, so that's we could probably just publish that there and stop the presentation here. Would anyone have any qualms about that? No qualms? Okay, I would have a few qualms about that. And just by looking at the graph, so let me zoom in here. So R squared, people know what R squared is. Basically crime in this data set, crime explains 15% of the variance in Boston house prices. That's pretty low, even though that's a highly significant. And what's the significance telling us? That it's a better predictor than the mean. So that the average, yeah, it's a better predictor than the mean. But 15% is pretty poor. Also, if we look at this diagram, we've a lot of our towns within Boston have no crime. So they're completely spread out across here. And in a linear model, one of the assumptions is the linear model is homogeneity of variance, which in simple terms means you can't have this. You can't have a fanning out of your variance around your model. It breaks one of the basic assumptions. Again, just looking at the slide. So let's get hypothesis testing too. Even though we were significant that crime is a significant predictor of house prices, in our data set, there's probably a lot more going on. So the next question I'd ask, and this is more about going on a journey with your data than finding an answer to a question and stopping there. So the next question I'd ask is there a better predictor of house prices than crime? So I've picked from my data set. So, well, actually, let's jump into R. Let's confirm those results that we saw in Tableau in R. So here's a really simple linear model referring to the Boston data set. Let me load that data set up in R. This is the linear model with house prices as the Y, crime as the X, or the house prices as the dependent variable, crime as the independent variable. Let's take a quick look at this. Our adjusted R squared in R is 15%. So again, that's exactly the same as Tableau, no problems there. And we see crime is a highly significant predictor, same as Tableau. But what happens if we include the entire data set? So I'm going to do this in R because for me, it's easier to do in R than Tableau. So it's just an extra line where I'm just adding in all the other variables. I can hear someone typing as well, if they wouldn't mind muting. That'd be great, thank you. So these are our outputs. We can see when we include all the other data sets that crime's not such a good predictor of house prices than some of our other variables. And the original study that this data is based on, that's an air quality rating there. It's a very significant predictor. But the one I'm actually most interested in, and this is quite a good predictor down here. Actually, RM's a good predictor, but that's just the number of rooms in a house. So of course that's going to predict house prices. Something I'm very interested in is lower status. That's probably what we now call socioeconomic status. And that's a factor that's been built in by this data. And I'd have to go back to the original methods to see how that was done. But it's highly significant. And I'd say it's a much better predictor than crime. Crime is there's probably some mediation going on between socioeconomic status and crime. But let's not get into that. And this is the ratio of blacks in the community. At the moment with the US, I wouldn't touch that variable. So let's go back to Tableau. So socioeconomic status is our predictor. Things look things look pretty good here. This is a much better model. We don't have all this clustering around the zero like we had with crime. We've got a good spread of data. This is where actually. So this is a basic model. We have a good spread around data. There's still some things that I'm a little bit concerned about, and this is where we can use R to return some values around the residuals. So when I say residuals, I mean the error. So the distance between our line of best fit and where our actual values fall. The distance between there, the closest point, is our error term. So and the way to do that is all we have to do is create a calculated field. I've already got one pre-prepped, and it's very simple. Let me try and zoom in there. So it's quite simple. We've got our arguments, which is our y-axis, which is the house prices. We've got our x, which is lower socioeconomic status. Our linear model. This is the fitted model. And then all I'm doing is asking after the residual values. There's a lot of other things that you can ask. I'm just asking for the errors. So all we do is we drag that on size. Residual, sorry. Compute the residual using across and down. So we've computed the residual. So what's happening here? Because if a value falls below the line, it's a negative value. And if it falls above the line, it's a positive value. So all we need to do is edit that in the shelf and put an absolute value around that. Pretty bog standard stuff. And now we've got the closer something falls to the line, that is the smaller the residual or the less error, then the smaller I've made the scatter plot or the value, the data point. The further away it falls, the larger I've made it. And this just gives us this just emphasizes, for good or for bad, it's probably bad modeling from the Tableau Viz people, but I'm not a Tableau Viz person. But for my mind, this gives us this emphasizes that we don't have a linear relationship. So let's just talk about that. What would be our next step? I've seen a lot of people remove outliers in this case. And Tableau is wonderful at this. You just select, oh, I think that's an outlier. I think that's an outlier. How's our R squared going? Oh, we're almost up to 60%. So we're already just removing some outliers. I use the word outlier very loosely, right? We're not measuring if they're statistical outliers. I'm just calling them outliers. So let's just keep removing stuff until we get what we want to see. And I've seen people do this. 62%. I'm getting greedy now. Anyway, where are we up to? 64%. So by removing a handful of outliers, and Tableau is so powerful it lets us do this very easily, with no justification, of course. Our model is now socioeconomic status now predicts 64% of Boston house prices. But that's bias. That's bias, is removing outliers. Even in my demo, in my slide here, I've got it to, 0.63, 0.9, so 64 as well. I don't really recommend removing outliers, and I don't think many people would, unless you know the data so well that you know that something is amiss. For example, someone built a mansion inside a ghetto or vice versa, then maybe that one value you might remove, but I don't think you should remove values to fit your model. So what have we got? We've got a monotonically decreasing relationship. We've got a linear model with a coefficient of 0.95. So this data's we've got R squared of 55%. So that's the coefficient of determination. So as socioeconomic status goes down, there is a logarithmic decrease in median house prices. Inversely, as SES goes up, socioeconomic status goes up, there's an exponential increase in house prices. So how did we do that in Tableau? Really easy. For right-click, edit trend line, exponential, boom, we've fitted the model. But what is Tableau doing? How is it doing that? There's a hint. I don't know if you can see that, but there's a hint in this model. I can't see it there. Let me go back to my slide. So if we look at what Tableau is doing, and again, we can apply the residuals into here, and I'll show that in a second to apply the residuals from R and emphasize the distance from our model that our values are falling. We can see that R squared, just by changing from linear to non-linear, we can see that R squared is gone to 65%. Yes, 65%. But we can't interpret that the same way. And that's because what R is doing is applying the natural log to median house prices. So our equation is now using the geometric mean, and we can't interpret the slope directly. And I think that's important to note. We need to take the inverse of the log to then interpret it, and then we'd probably only use confidence intervals to interpret that data. It's still, I think the point to make here is it's still linear regression. So what would be our next steps? And I'm assuming I only have a couple of minutes left. So just before I go on to the next steps, I should flick the slide. So again, to apply those residuals inside R was really simple. The only difference, I'm calling R, and the only difference is I'm putting the log around there. It's the same linear model. The values are the same. It works exactly the same, but it now applies it to here. I would be reluctant to go down that path using Tableau. I think Tableau's benefit is it's great for analysis and great for data exploration. To make claims, it doesn't have the statistical power to make evidence-based claims that a statistician might make. Again, let's check some of the data in R. Our adjusted R squared for our linear model with using lower status or socioeconomic status, 55% again. Let's take the log. Let's confirm that that is what Tableau is doing. Yep, looks right. Our adjusted R squared is 65%, is what we saw in Tableau. Our equations, our coefficient estimate. Now it's a log. Now it's applying the log. It's not interpretable, and that's the same as what we saw in Tableau. So next steps in estimation. I personally wouldn't stop there. It depends what you're trying to prove. Maybe that's enough. but in econometrics, if you were going to put money on house prices and predicting house prices for the future, that model would be quite risky to do that, I think. So let's use R to do some alternatives. Let's plot. So pretty straightforward. The red line, if you could see it, the red line is our linear regression, and the blue line is, I have to refer, is a polynomial, is a locally weighted polynomial regression. And we can see that it's actually extremely close to what Tableau looked like, and Tableau looks a lot better. These are default options really for both apps, and it'd be hard to put this model in front of one of your users, whereas the Tableau stuff looks so much better.
So Peter, we actually have some questions that have come
up. Sorry.
So when you're ready. So someone asked, is there an easy way to test for bad leverage points and outliers to show them as the standard SD, standard deviation, in the errors? So that's...
Is there a bad way to test for bad leverage points and outliers to show them in standard deviation? I'll ask the other question. Yeah, R will run on the server.
Okay.
R is run on the server. To look at leverage points, I would say, let me skip ahead because I was going to briefly touch on that. How much time do I have left?
You need to start wrapping it up.
Yeah, okay. So the test on, I would do that in R. I'm not aware of anything in Tableau that would do this, but we can look at our fitted model in R, and we can look at the different, values, QQ plots and the like.
Peter, it's Fee here. You can also respond to Caleb for his question in a little bit more detail offline. Give you the opportunity to maybe run him through it in a WebEx session, or put something up on one of our blog sites.
Yeah, or I don't think I really have an answer to that question apart from looking at some of the residuals and looking for those points.
Okay.
So, as a final little point, and I don't know how to do a lot of these things in Tableau and link them to R. So running, this produces something very similar. This produces something very similar to what we produced in R. Really, what is, and this is just as an extra aside, what you'll probably want to do is use maximum likelihood. And I've got the code here for maximum likelihood in R. And we can see there, and maximum likelihood is another estimator that, again, it's a log estimation. But I won't go into that, but it uses basically matrix algebra to get our coefficients and our estimates and to find the best points. So that's probably me. Thanks to Tram from MIP and Gary from Swinburne for giving me some points on this. Yeah, is there any questions? I should flick over to the next participant, no? Next presenter.
Thank you so much, Peter. And if anybody has any questions for Peter, we can certainly follow up offline. And as Fee mentioned, we can also share information that can go out to all of the recipients or all of the registrants, as well as we can also post it to our Fringe Festival website as well. So if your head is just zooming with R and you think of questions later, certainly feel free to follow up. Peter, thank you so much.
Pleasure.